Hello friends, welcome to my YouTube channel Make Maharashtra. It gives you more educational videos. Now previously we have seen the temperature effect of the hydrodynamic bearing. Now we'll start with the selection parameter of the bearing. While selecting the bearing, we must know the parameters. So what are the important parameters that I'll tell you one by one. So first is L by D, that is length of bearing with respect to diameter of bearing ratio. As I told you in previous session, L by D is equal to 1 by 4, 1 by 6, that will occur, but the best L by D ratio is 1, correct? Why? See, first of all, the point is in L by D ratio is changed, then it will affect the performance of the bearing. This is the very important part, first part, which will affect the performance. Why? Because very simple, if the length of the bearing is increased, you can see average pressure also increased, the area is increased. If length is reduced or L by D is equal to 1, I have mentioned over here, then average pressure is less, so no load coming over the bearing. But in case of the L by D ratio more, the load average pressure is more. So this point I have covered. It will affect the performance, it will affect the due to the pressure. Next will be the basically what happened, the bearings are situated to the shaft for getting the rotations of the give the rotation to the shaft. So the shaft is designed generally on the basis of strength, not on the bearing capacity. It will define on the basis of strength. So on the basis of strength, shaft can be designed. So the designer is design the bearing on the basis of bearing capacity. IESME code. And in case of the designing of the bearing, designer should check the capacity of the bearing. What will be its capacity accordingly? Clear? So that's why L by D ratio is preferably 1. Next, the selection of the parameter of the bearing. Now in the case of the bearing selection of parameters, what happened? Second part is load per unit projected area. This is very important, and we know the projected area P is equal to W by LD, which we have seen in the Raymundi's and Boyd method. So it means that area is equal to, that is L by D. Now first of all, very important, that depends on the bearing material. The projected area, load per unit area, is depends on bearing material, which is either it is ductile, cast iron, it is having yield strength or not. First thing. Second thing, it depends on operating temperature, nature of the load, service condition, where it is operate and what will be the service condition, for what purpose, pump, for pump it can be used, or for crane it can be used. So for centrifugal pump it can be used. So accordingly we'll have to define the condition. So that is comes under the load per unit projected area. Next, third parameter is startup load. Startup load means at the initial condition sudden torque is generated, so that will be the startup load. So startup load in that case will have to, basic structure is static and at that time shaft is stationary. For that condition we need to consider the startup load should not be more than 2 Newton per mm square. If it is more, there might be chances of the breakage of the bearing. Next parameter is radial clearance. This is very important. If radial clearance is small, then velocity gradient is small. If it is more, it increase the cost of bearing, hydrodynamic bearing. So that is the purpose of radial clearance, and we know C is equal to R minus R, radius of the bearing and radius of the shaft. Fifth parameter is minimum oil film thickness, that we know HO. Generally what happened, it governs the load carrying capacity and reduce the friction. This oil film thickness, it will carry the load as well as reduce the friction. And lower limit of the minimum oil film thickness in between shaft and bush is 0.002 times radius at least. Beyond this, there will be the contact in between metal to metal to surface and friction will be created. This is also important parameter. Next is 6.1 is a maximum oil temperature. Now what will be the temperature we need to keep? So generally, if the oil temperature many times it will exceed for 100 and above, so in that case we need to take care, as per the standard we need to take care of the temperature, because more temperature viscosity is reduced and that effect of the wear and effect of the avoid the wear and friction is reduced. That's why generally the temperature range is limiting minimum limiting temperature is 90 degree will have to keep for the sliding contact bearing. So these are the basic 6 parameters which we have studied for the selection parameter of the bearing. First is L by D ratio. Why? I had explained you. Then second one is the load per unit projected area, that depends on the bearing material, operating condition, nature of frequency and service condition. Third one with the startup load, it should not be more than 2 Newton per mm square. Third one is the radial clearance, for if it is more, then cost and material is required more, and again it is costly. And next one is the minimum oil film thickness. It should always required limit in a value. Minimum limit is 0.000 twice of radius of the shaft. And last one is the maximum temperature oil, and that will be the temperature minimum 90 degree temperature. The limiting temperature value is 90 degree. Clear? So by this way I have explained you the 6 parameters which are important for the selection of the bearing. I hope you understood. Dear friends, please revise the things which I told. Please revise it. Then and then you will remember. Clear? Try to solve the assignments. I have already uploaded the assignments, so do the assignment from your side. Okay, we'll see the numerical part in next session. Thank you.